what is the idea of recursion? So let me just give you guys an example. Recursion is a very beautiful idea. In fact, it's a very, very powerful idea, and we won't see all the power today. But we talked about functions. We talked about functions calling other functions. Now we have an interesting question. Can a function call itself? In particular, can a function call itself before it has been fully defined? Right? That seems a little strange, right? It's like a snake eating its own tail. Can a function call itself? And the answer is yes. Functions can call themselves, and it's actually quite interesting to have functions be able to call themselves. And the example that I'll use is a mathematical example. It's not heavily mathematical. So first I'm going to make a definition. I hope all of you have seen factorials before, but I'm going to just define what a factorial means. So factorial is when we write n with an exclaim next to it. And what does it mean? Well, it means that I take, if for any number, I take the number, I reduce it by 1 and multiply. I reduce it by 2 and multiply. I reduce it by 3 and multiply, all the way up to 1. If I multiply this out, that's n factorial. So for example, 3 factorial is 3 times 2 times 1, which is 6, right? So that's 3 factorial. So how will we compute this? Now, of course, if you knew that you only needed 3 factorial, you could have written 3 times 2 times 1. But I want to write a function that can compute any arbitrary factorial. Now, let me show you how to solve this by recursion, okay? So the idea is with recursion is, first of all, when does this calculation stop? If I start with n, this calculation must stop when I reach 1, right? Or when I reach 0, really. It should do 1 and then stop at 0. So the first thing with recursion is there should be a stopping step or a final step. So what I do here is I check if the value of n is 0, and if it is 0, then I return 1 and I stop. So that's a simple one. Otherwise, I return n times n minus 1 factorial. So you see, I've reduced. So I've taken. So let me write this here below. I have taken the value n, and then I have taken 1 less than n, which is n minus 1. And now I'm going to call factorial on that one, right? So I've basically done only one step. You see here, I have multiple steps to do, but I have done only one step. But now when I go inside this factorial, it will do the next step, right? Because it will take n minus 1. So when I run the next factorial, I'll get n times n minus 1, and then it will be factorial n minus 2. You see, it will keep on going like this, right? Next time, I will come back to this again one more time, like next time. But it's a very powerful idea, and I want you guys to understand how beautiful it is. So it will keep on going like this until it hits 1, or until it hits 0. When it hits 0, it will stop, right? And it will compute the factorial. So let's just try this. What is 3 factorial? Anybody knows the answer? We can do that at 6. Okay, it's up there. So 3 factorial is 6. What about 5 factorial? Can somebody post the answer, run 5 factorial and tell me the answer? Yeah, 120. So yeah, by the way, I memorized some of these factorials because I use them all the time, okay? So that's it. So you've learned a very powerful concept here. Again, don't worry. I wanted to introduce you to something really, really powerful, right? Which is functions can call themselves. And I want a placeholder here. If you remember only this much, that functions can call themselves, that's enough. And then the second thing is that we can use this as a technique to solve big problems by breaking them into smaller and smaller subsets. So it can become a very powerful way of solving problems. And I'll solve this for you another time. Oh, and n double equals 0. Again, this is, you know what, next class, I'm going to spend a lot of time on this if statement. You see, one of the challenges I face in arranging material for you is I'm sometimes have to go one step forward just to show you something interesting, because I have so little tools sometimes, okay? So don't worry at all about this if statement. You're not going to use it anywhere else for this class, but the next class, and this is a beautiful preview for the next class, this is going to be all about these if statements and how do we do logic in programs. So do not worry at all if that part is not clear. The only thing I want you to learn from this example is that the factorial function can call itself, right? And if a function is going to call itself, there's an important idea we need to have, that you have to stop. If you don't stop, for example, if I delete this line, this function will keep on running. It will never come back, okay? Now, I think somebody answered on chat. I will just say it to you that so this is very important, right? That there are two symbols here. There's there's the real equality, equals. So let me just mention this, something food for thought. There's the real equals in the language that we use when we say is A equal to B. And then there is assignment, right? As Rajesh said and others have said, if I say A equals 5, you see the difference between this. It's a very profound question, right? If I say A equals 5 like this, A equals is, so I'm, in this case, I'm checking is A, actually I should really, to be precise in English language, we might say is equals, right? Is A equal to 5? But here, when I say A equals 5, it's not checking for equality. It's saying, please take the value 5 and set A equal to it. So this, as was pointed out, is assignment. You assign a value. This is a very important concept, right? Here we assign a value to A. Here we check whether A is equal to 5, right? So this is the check or the comparison that's going on, right? Again, we'll spend next class, we'll spend a lot of time on these comparisons and the if statement, etc. Okay. So for now, I really, like I said, I just draw your attention to recursion in functions. Now, I have a longer example of this traveling salesman problem. Why don't you guys just take a read of it? See if you find it interesting, and we'll talk about it. I will cover it next time if you have questions, okay? I put it there really because I thought it's a very fun problem.